All right, in this video we're going to go through some of the more fun circle problem solving area type of questions. So let's start with this one. This is our donut here. It's asking us to find the area of the shaded region. Now I have our area formula up there in the corner, pi r squared. We're going to need that. So in this problem, if you look at it, there's basically a large circle there, which is represented by that. And then if I cut out that inner circle, so subtract that area of that inner circle, then I would only be left with the donuts area. So that's what we're going to do. We're going to do the shaded area minus, the shaded area will equal the large circle minus the small circle area. So that basically will look like pi r squared minus pi r squared, and I have little subset letters in there, the large area and the small area, because they'll have two different radii too. The small circle will have a different radius than the large circle. And actually it's easier to kind of start with the small circle here, so let's take a look at that first. And the reason it's easier is because I can see right there that the diameter of the small circle is 10. So the radius would just be half of that, it would be 5. So I can plug in pi times 5 squared for the small circle. The small circle is pretty straightforward. It's the big circle that's tricky. The big circle diameter is the entire way across, which is actually all three of those combined. It's 11 plus 10 plus 11. So that would be 32 when you add all three of them up. That's our diameter for the large circle. So I have to do half of that to get the radius of the large circle. So that would be 16 for the radius. Once I have that, I can plug it in for my radius of my big circle. So I'm just going to do pi times 16 squared minus pi times 5 squared. Now if I do 16 squared, that's 256, and if I do 5 squared, that's 25. So I have 256 pi minus 25 pi. Now here's the part where it gets interesting. Before you even plug in your approximation for pi, you can actually combine these two terms. It's just like in algebra where you have, if I had 256x minus 25x, I could subtract those coefficients. You can do the same thing because these are both in terms of pi. So I could just do, the 256 minus the 25 to get 231, and that's in terms of pi. So I've done all the math that I can possibly do before I plug in my approximation. If you had plugged in 3.14 for both of those individual terms, you'd get the same answer. You just have to do that math twice instead of here where I only have to apply the approximation once to 231. So when I multiply 3.14 times 231, then I get 725.34, and those are square meters. So that's our donut. It's pretty cool. I like that one because has us combining pi terms, which is a skill that comes in handy for later problem solving. So let's take a look at this next one. This next one here shows sort of like two quadrants, or a square and a quadrant, or semicircle and a little sliver, however you want to think of it. We're going to look at it as a square. There's a square there. It's a 4-inch square, and then we also have our quadrant there as well. And we're going to just combine. The shaded area will be the quadrant area plus the square area. So let's figure out those. First, obviously, the square area is just going to be side squared. The quadrant area is going to be a quarter of the area formula. So it's 1/4 of pi r squared. And then the square is pretty straightforward. I'm just going to do 4 times 4 to get, or 4 squared, that'll be 16. And then for the quadrant arc, remember we're doing a quarter of the radius. Now the radius I can steal from the square side. It's 4 inches for the radius of that circle. So I'm going to do a quarter of pi 4 squared, since the radius is 4. 4 squared is 16. So actually they're both 4 squared there. And then I can do a quarter of 16. That's what I like to do first. So 1/4 of 16 is 4. So that's 4 pi. Or think of it as a quarter of 16 pi is 4 pi. And then I can't combine those two terms this time because they're not like terms. They're not both pi terms. One is a constant term, 16. The other one is a pi term. So I'm going to plug in my approximation now. So I'll plug in 3.14 for pi. Multiply 4 times 3.14. That gives me 12.56, and then I can add that 16 finally to get my final answer of 28.56 inches squared. So that one was a little interesting. You had to steal the radius off of the square and just add a quadrant to it. The next one's pretty interesting. So there's a hard way to do this one and an easy way to do this one. I'm not going to go through the hard way all the way. I'll just show you kind of how you would do it. So basically the hard way to do this is realizing, okay, I have 2 quarter circles or 2 quadrants. So that's quarter of a radius or quarter of an area formula for each one. So I could find those 2. And then finding the slivers here, like one of these little slivers, is kind of tricky because you basically have to find the square area, which since the side is 30, this would be 15 by 15 square, which is 225. And then I would have to subtract from that the quadrant arc, which we already said was a quarter of pi r squared, or not the arc, I'm sorry, the quadrant area. So I would have to subtract the quadrant area from that square, and then that would leave me with that little sliver. And I'd have to do that, or I could double that for the other one as well. Now you could do all that math and it will work out to be the same answer, but there's actually an easier way to do it. And that involves realizing that the corners, the 2 shaded sliver corners, can actually be moved. And if I move them to the other corners, I just get 2 squares. You know, I could pick those areas up and plop them in those corners, and then I just simply have the 2 shaded area squares. So that would be 2 times side squared, and we already said it. They're both 15 by 15 squares, and that would be 2 times 15 squared. 15 squares was 225, and then 2 of those ends up being 450 millimeters squared. So again, you can do it that other hard way, and it's pretty interesting because you'll end up subtracting out pi terms and stuff like that. But I'm not going to show that in this video just to save time. We're going to go on to the last example here. So the last example is our Mickey Mouse example. If you watch the circumference video, we did this one with circumference, but now we have to do it with area, and it's actually even easier. So we're looking at 3 circles. That's a semicircle right there. We're looking at the area of another semicircle right there, and then we're looking at another semicircle right there. So all in all, we have 1/2 pi r squared 3 times, right? A half, and a half of an area formula. So altogether, that's 3/2 of pi r squared, or basically 1.5 areas of a circle, right? Because 2 of them will make a whole circle, and then there's a half circle on top of that. So I'll just do 3/2 of pi r squared. So I just need the radius. The radius, since hopefully you can see the radius is 12. So we're going to plug that in. We're going to do 12 squared is 144. And then, as always, I like to do the 3/4 of 144. So you could either do 1.5 times 144. You could divide 144 by 2 and multiply by 3. Or multiply 3/2 times 144. Either way, you're going to get 216 pi. Now I'm ready to plug in my pi approximation. So I'll just plug in 3.14 for pi, and when I multiply 216 times 3.14, I get 678.24, and those are square meters. So that one was pretty interesting. So good luck.